Okay, we have the mineral composition. Now, there are approximately 4,000 known minerals uniquely defined by their chemical composition and internal structure. From, the, from your previous knowledge about this topic, you are now familiar with the minerals such as quartz, halite, or rock salt, gold, and diamond. Now, many materials found on the Earth's surface are not minerals. Example of this are, as I mentioned a while ago, we have water. So water is not a mineral because it is not solid, though having the same chemical formula with ice. We know that ice, okay, this one is a mineral. Okay, so this is a mineral. And coal is not a mineral because it is made up of plant remains and it lacks a particular composition, and its atoms are not arranged in an orderly manner. Although they are produced by living things, shells of such marine animals such as clams are composed of minerals. So the shell is made up of minerals. So out of all the elements found on Earth, only 8. Okay, so only 8 elements make up 98.5% of the Earth's of the crust's total mass. So 98.5% of Earth's crust is composed of these elements here: oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. And out of this, we have majority of, or more than 90% of the minerals on the Earth's crust are compounds containing oxygen and silicon. And this particular group is called silicates. So later we are going to discuss the different mineral group classifications. So most minerals are compounds. Quartz is an example of a compound of silicon and oxygen. Galena is a compound of lead and sulfur. So later, we are going to have some images or pictures of the minerals that I have mentioned. So a few minerals, however, contain single elements and are called native elements. So these are minerals that exist in their purest forms, some of which include silver, copper, sulfur, and diamond. Often, differing types of minerals, compounds, and native elements are found mixed together, and such mixtures, as I have mentioned, are called rocks. That's why we can say that rocks are aggregates of minerals. So here we can see the common elements of Earth's crust as in as shown by percent or mass by percent. No, percent by mass. So we can see here that majority of the Earth's crust is made up of oxygen and silicon, or what we call as the silicates. Okay, we have silicates. So how are minerals formed, if you're going to ask yourselves? So many of Earth's minerals form from magma. We know what magma is. Okay, it's the melted rocks underneath the earth. So magma is found underground. They are melted rocks. As the magma moves closer to the Earth's crust, it begins to cool. As it cools, the atoms inside the magma condense, moving closer together until it solidifies and forms crystals. So a crystal is a regular geometric solid with smooth surfaces. So crystals, the shape of crystals is determined by the internal arrangement of atoms. So in fact, I mentioned the orderly arrangement of atoms as being one of the characteristics of a mineral. So crystal size is determined by the amount of time it takes the magma to cool. So once it's outside, there will be example like volcanic eruption. So fast cooling, it produces small crystals. So there's a limited time or a small time for the crystals to form. That's why we have small crystals. Slow cooling, if it's rock forming or intrusive rocks cooling inside or underneath the or underground, we can form large crystals. Some minerals form when water containing dissolved substances evaporates. So later, when we talk about how examples of mineral ores, we can see that some of them are formed via this process. So we can see small and so crystals can be actually very minute, such as snow crystals, and they are in different shapes. Okay, so it can be like this or like this. Okay, and this hourglass shape crystal, snow crystal, and it can be also gigantic or huge, such as the rock gypsum in Mexico.